Welcome to today's lesson. Our learning target, I can investigate, justify, and apply translations on the coordinate plane. So we're moving on to our second type of transformation today called a translation. If you notice, we're going to use the capital T to represent translation. Yesterday we talked about reflections and we used lowercase r. Now, before you watch this video, you should pause it for a second and try to fill these in on your own using yesterday's notes from reflection. So I would pause it, take a minute, fill these in, and then check your answers with mine. So what is orientation from yesterday? It's the ordering of your vertices or your points. There were two types of orientation. We had clockwise and we had counterclockwise. An isometry is a transformation that preserves distance. Now, if you remember another word for distance, length, the length of the sides of the figure. Two types of isometry we talked about, direct and indirect. Now, direct means that distance and orientation are preserved. Indirect means distance but not orientation are preserved. So yesterday we determined that a reflection was indirect because distance or length was preserved, but the orientation changed. Don't forget you can call indirect opposite or reverse. Those are other names for indirect. And we talked about, is a reflection an isometry? Yes. What type did we say it was? It was indirect, since distance was preserved, but orientation was not. So we're going to move on to translation. Now, another word for translation is a slide. Just like yesterday, another word for reflection was flip. So this is another rigid motion. Rigid motion is just another name for isometry. And it's called a translation or a slide, in which every point of the figure is moved in the same direction and the same distance. So I want us to describe how we translated, or we took ABC and slid it to the image called A prime, B prime, C prime. What you do is you pick one coordinate from your original or your pre-image, and you figure out how you get from your pre-image point to your image point. So we're going to count the units. So if you were to start here, we're going backwards how many? 1, 2, 3, 4, 5, 6, 7, 8. So we're going left 8. So that means we're going to be right here. And down how many? 1, 2, 3, 4. Down 4. Remember, if you move in the left or right direction, that's your X direction. And if you go up or down, that's your Y direction. So there's a certain way to express a translation. Just like yesterday, there was a certain way to represent reflection using lowercase r. There's two different types of notations you can see for a translation. Remember, capital T for translation. Remember, we want the X to come first, as if it were an ordered pair, and the Y to come second. Now, why did I put left 8? Because we're going backwards 8. Why did I put -4? Because we're going down 4. On the coordinate X, Y, or a translation on X, Y, and that would map to X, translation of X minus 8, Y minus 4. Either one of these notations can be used. Now, is the size of the object preserved under translation? Yes, the size does not change if all you're doing is sliding your figure somewhere else on your graph. So yes, remember, preserve means stays the same. Is orientation the same? Two types of orientation, clockwise or counterclockwise. Let's check the orientation. In my pre-image, I'm going from A to B to C. So that's counterclockwise. In my image, I'm going from A prime to B prime to C prime, which is still counterclockwise. So as opposed to a reflection, under a translation, orientation does remain the same. We started with counterclockwise, we remained with counterclockwise. So is orientation the same? Yes. Now we talked about the two types of isometries up at the top. We talked about direct or indirect. Since orientation and size or distance remains the same, we would consider a translation direct. The length of the side stays the same, and so does the orientation. Okay, let's turn the page. Is a translation an isometry? We just said yes. And if so, what type? A direct isometry. Okay, here's the rule for the translation. All you're going to do is simply take your x value and you're going to add it to whatever value they give you for the translation. So say this was, let's write the rule first. So again, you're going to add your x value to your x value from over here. So a plus x or x plus a. Same thing with the b and the y. Those two match up, so you're going to add those two together. Let's see how you apply this translation rule. So go down to exercise 1. It says determine the coordinates of the image. Remember, that's what you end up with after the translation of 5, -3 under a translation of -2, -1. So if you wanted to write this using the proper notation on 5, -3, what we're going to do is we're going to add these two together. So a -2 plus 5. And then we're going to add these two together, -1 plus -3. -2 plus 5 is 3. -1 plus -3 is -4. And there's our image point. Number 2, determine the coordinates of the image of point -8, -3 under the translation xy maps to x plus 4, y minus 1. This arrow means maps to. That's how you read the arrow. So if you were to take this, your x is -8, your y is -3. We're going to apply our rule. So it's -8 plus 4 and -3 minus 1. We're going to do the algebra. -8 and 4 is -4 and -3. Now, you can say -3 minus 1 or -3 plus -1. It doesn't matter. You're going to get the same value. So -3 plus -1 is -4. And there's our image point. Number 3, determine the translation that maps -5, 5 to the point 7, 1. So we want to find the rule for the translation this time. We want to figure out how we get from -5 to 7 and how we get from 5 to 1. So a lot of people can do this in your head. -5 plus or minus what would take you to 7? 12. -5 plus 12 takes you to 7. 5 plus or minus what would take you to 1? A -4. Now, if you can't do it in your head like I just did, there's another way to simplify this. And you can set up a simple equation to solve for the 12 and the -4. So we're going to say -5 plus what gets me to 7. And if you were to solve this, you're going to add the 5. And you're going to get x equals 12, which is what we said our x value was. You can do the same thing for the y. Let me see if I can fit it in here. We want to figure out how to get from 5 to 1. So 5 plus what gets me to 1? I'm going to subtract the 5, and y equals -4, which is what we said over here. Problem 4, a translation maps this point to this point. What is the image of 1, 4 under the same translation? Let's take care of this part first. We want to figure out how we're getting from -2, 5 to -4, -4. So again, you can figure it out in your head, or you can set up these equations to figure out how you're getting from -2 to -4. How do you get from 5 to -4? So T for translation. If I subtract a 2 from the 2, -2 minus 2, that'll take me to -4. Now, if you can't do that in your head, set up your equations. How do you get from 5 to -4? Well, you can subtract 9. 5 minus 9 gives you -4. Now, that's the first part of the problem. They want you to find the image of 1, 4 under this same translation. So I'm going to apply this translation. So 1 minus 2 is -1. 4 minus 9 is -5, and there's my final answer. You're going to do number 5 on your own using a separate sheet of graph paper, and you're going to finish that off.